Hmm. So car number two has some kind of problem because, oh, Maheen, you are not supposed to. Now, three cars are observed moving on a track side by side. This is the person who is observing them, and he is recording the time and the distances from him for the three cars. So he recorded these three rows of data for three different cars. Now, as we can see, car number one, when the observation begins, it is at a distance of 10 meters. After a second, it is at a distance of 20 meter. What does that mean? How much distance the car has traveled in this 1 second? It has traveled a distance of 10 meters. Now, in another second, car becomes 28 meters away from the person. So how much distance it has traveled between 1 and 2? It has traveled 8 meters. And then it has traveled 6 meters in the next second and is traveling um, 4 meters in the next second, 2 meters in the next second. So what is happening to distance travel in every next second? Object is traveling less and less and less distance in every next second. So this is a decreasing speed. And then we plot all this information on a graph like this. This is time, these are distances, 10, 20, 28, 34, 38, and 40. And you can see when we make the distance time graph, it has a decreasing gradient. The graph is steeper in the beginning, and then the steepness is gradually decreasing, 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 and it almost becomes flat at the top. So it means decreasing speed on distance time graph has a decreasing gradient. Now look at car number two. Car number two travels 10 to 12 and 12 to 16, 16 to 22, 22 to 30, and 32 to 40. So 2 meters, 4 meters, 6 meters, 8 meters, and 10 meters. So it is traveling more distance in every next second. That means this car is having an increasing speed. Look at the graph of this car. When I plot distance against time, I get 10, 12, um, 16, and so on. And I hope you can see that the steepness of the graph is increasing. This is said as the gradient of the graph is increasing. And if we are having an increasing speed, a distance time graph should have an increasing gradient. Constant speed, constant gradient. So decreasing gradient shows decreasing speed here, increasing speed, hence increasing gradient. And the last one is constant speed, so constant gradient. Now, let's move to the next topic. Today, we'll be learning about motion and different aspects of motion. Now, speed, it can be constant or uniform. If speed is constant or uniform, it means we can use the formula speed equals to distance divided by time. Only if speed is constant. This formula can only be used if speed is constant. What if speed is not constant? Variable speed. Variable speed means speed changing. When speed changes, another quantity comes into being. That is acceleration. Acceleration is change of speed divided by time. Some people remember it as v minus u over t, or you can remember as delta v over t. Just 1 second. So this is the derivation of all the equations of motion. The first equation is actually the rearrangement of the acceleration formula. A equals to v minus u over t is rearranged to make v the subject. T goes over there, multiplies, and it becomes u plus at. And this is the formula for distance travel if an object is moving with a variable speed, but with we know the average velocity of the object. We can multiply average velocity with time to find out the distance traveled. Now, average velocity, as we know, if object is moving with constant acceleration, we can find it by adding the first and the last speed with 2. And time from this formula, look, a equals to v minus u over t. If we make t subject of formula, t becomes v minus u over a. Putting the value of average velocity and time back into equation s, which is average velocity multiplied by time, it ends up v plus u over 2 multiplied by v minus u over a. Denominator multiplies with denominator, numerator multiplies with numerator, a plus b into a minus b. Very famous formula that you remembered or worked with in O levels or IGCSE. A plus b into a minus b is a square minus b square. So it becomes v square minus u square over 2a. And we can shift this 2a from here to here, and it becomes 2as equals to v square minus u square. Further, if we want to, we can rearrange it to 2as plus u square equals to v square. This thing is known as the second equation of motion. Now, the starting from the same formula, distance equals to average velocity multiplied by time, we can replace average velocity with v plus u over 2, and then v can be replaced by u plus at, as we have made the first equation v equals to u plus at. We have replaced v with u plus at, and it becomes this. Rearranging and sorting ends up as s equals to ut plus half at square. Deriving equations is very important for the syllabus of AS. We have to make or derive sometimes some equations, and we need to know how we can put in some variables and take out some variables when needed. Examiner can simply ask us to make a formula so and so. So we need to know how can we do that. And this is a kind of introduction to the process where we start finding easy equations. And key to the variable is given over here. And these are the equations, like last three are equations of motion. First two are very good formulas, very helpful formulas, but they're not called any equation of motion. The last one is first, second last is second, and the third last is third equation of motion. And these two are just formulas, not called equations of motion. Every single formula is missing one of these 5 variables, and that helps us to make a decision that in which case we can use which equation of motion. In the next lesson, we'll be practicing some questions using these equations. Till then, take care. Thank you for watching.